Okay, so just a quick survey of the room. Like, who here has used Scala before? Like, at all? Oh, actually, almost everyone. Who uses it as like their primary language day to day? Okay, interesting. So it seems like most of you have used it. Maybe you, I guess the ones who've used it but don't use it every day. Is it like raise your hand if you'd say like you're a beginner or like intermediate? Okay, that's cool. So this talk was basically intro to Scala, like some as like from the perspective of like a advanced Java programmer. So it seems you know some stuff about Java. So let's get started. Who am I? I'm Chad. I work at Twilio, who has an office in Tallinn. I've been there for about 5 years. I actually worked in the Tallinn office for 4 months this summer, so that's how I ended up in Estonia. I actually started at Twilio as a Python developer. I think a lot of Scala people move over from Java, but I was not that case. I was actually came from Python, so I guess I have a little bit of a different take on Scala. What actually happened was there was sort of more pressure to share code between the teams, and because we were sort of implementing the same thing over and over, and I didn't want to convert the stuff to Java, so I found a new language that was nice and compatible with Java, could still share code, but it didn't have to write Java. So hopefully that's not an unpopular thing to say in this room. What does Twilio do? So I don't know if any of you have heard of it. Basically, we're an API for communications. So we have REST APIs. You can send SMS, make phone calls, IP messaging. We allow like any developer who knows nothing about telecom, they can write an app in like 10 minutes that makes your phone ring. So that's what Twilio does. Just a quick commercial. So at Twilio, we have probably about 40 Scala programmers. There's like 3 main teams that are using it like primarily. I was on the messaging team for about 3 years, and now I'm on a different team that's not listed here that uses Scala. Actually, yeah, I'm on the operational tools team. I guess I did list it. So let's get started. Like, why would you want to use Scala? Well, compared to other functional programming languages, if you've already been sold on functional, like why Scala? Well, because Scala compiles a JVM bytecode, and that means you get really good interop with the existing Java ecosystem. Java has like a huge ecosystem, as I'm sure you're all aware. There's lots of ready-to-use libraries, and if you choose Scala, like you have that, backing you up. And the performance is also comparable to comparable to Java, since it compiles the same bytecode, but it has a nicer and more concise syntax than Java, as we'll see. It encourages a functional style, which, as I'm sure many of you know, it means that your data should be immutable, and you should try to avoid like mixing your side effects and your logic. And even though it's a functional language, actually I would argue that Scala is more object-oriented than Java, and I'll try to defend that claim in the slides. And I would also argue that the Scala's advanced type system allows you to catch more bugs at compile time, and I'll try to prove evidence for that. So to get started, we should talk about how you define variables. So there's sort of 4 ways you can think of as for defining variables. The first one is val. So val is like final in Java. It's saying this is a value. It'll always be this. You can't change it. Maybe more traditional variable is the next one, var. It's evil and mutable, and you should try to avoid it, although you may need it sometimes for optimizations. For methods, we use def. And the real difference between a def and a val in this case is that a def is going to get exercised every time. So there's also something in between a def and a val called a lazy val, which only gets evaluated once, the first time you call it, and then it sort of caches that value. So I have some examples here. Here I've reassigned my var to 5, and I have a def here. Defs can also take arguments because they're methods, basically. So you can see I have these 2 arguments, x and y. And here's lazy val. So if we reference this my other lazy val, the first time you reference it, it's going to do the print line, and it's going to calculate the value, and the next time it's just going to return the value. So it's sort of like a cached thing. Some more stuff. So for when you have a single expression on the other side of your equals, those curly braces are actually optional. So here we have my other def. You can see there's no curly braces because there's only one expression. And actually, if you have no arguments, then even the parentheses are optional. So here I have some method, I've defined it 2 times, and I haven't even given it parentheses the second time. And just like when you call it, same thing, you don't actually need the parentheses. And this makes it the line between vowels and defs a little more blurry, which can be useful sometimes. There's also not a lot of restrictions on how you name things. So here I've made a def, which is a pointing finger, and the first argument is a star, and I add 2 to the star. It's also optional to have this dot. So I could have equivalently said Meister take n instead of Meister dot take n. And just a sort of a hint about what the implications of this are. So when you look at myint plus myint, what you're actually doing is calling a method called plus on the myint object and passing it an argument. So you can also nest defs like this. So I have a def on the inside of my def, and this allows for a sort of better abstraction. You can think of it as kind of like private. Scala also has private, so you can use that too. But this is like sort of even more private. It sort of prevents you from polluting your class's namespace if you have a helper function that's only used inside one method. And we can also, of course, have vowels inside defs as well. So one thing to note is that if you do this, then you can't easily test that inner method in isolation. So keep that in mind if you're going to do it. Defs have default parameters. This is like something that I think every language should have, and I can't believe like new languages don't have this sometimes. So a default parameters means you can set what the defaults will be here, and you can override specific ones. So this example right here, we can set the third value to 4, and then we can get 1, 2, 4. So this is like super great. I'm a huge fan, as you can tell. You can also have multiple groups of arguments in a method. So in this method, which is called currying if you're into functional programming. So here I have a method called mult that does a multiplication, but it takes 2 different groups of arguments. And I can just apply the first argument and get a new thing, which is basically a function that does a multiplication with the number 3. So I have mult3, which I passed it just 1/2 of the arguments it needs, and then I can pass it the second half later, so I can multiply by 3 here. Another way you can do currying is if you have like an existing function that is not using the grouped parentheses, you can use this little underscore syntax. And then, so here I have an add that takes 3 arguments. I basically say underscore as like a placeholder to say these are arguments coming later, and I can pass them on later, like this. So strings are basically the same as Java strings. It's using Java lang string. It's already an immutable class, so we don't need to have our own for Scala. But there's some cool stuff you can do with strings. You can have multi-line strings if you use the triple quote. If you've used Python before, you've seen that feature. You can also do like string interpolation. So if you put an S in front of the string, you can now like pull variables into your string, and this happens at compile time actually, not like a string.format that would happen at runtime. So it basically just does like a string builder into your code. And then if you want to call an attribute on that thing, you have to use these curly braces. So primitives, actually Scala doesn't have primitives. Everything's an object. And here's a little object hierarchy. This is actually an old picture I got from the internet. The Scala object no longer exists, apparently. So there's like sort of like 2 sides of the object hierarchy. There's like the traditional one. This anyref is basically just the Java lang object, and any val is basically all these things that wrap the Java primitives. And so when you're writing Scala, it's like everything's an object. You can call methods on everything, even integers and booleans. But actually at compile time, these are going to get turned into either the boxed integers or the boxed primitives if necessary, or it'll keep them as the real primitives. So you don't have to worry about it most of the time. There's also tuples, which every language should have. If you've ever written Java, you probably had to write your own tuple a few times, and it's probably annoying because you have to implement equals and toString and like all these boilerplate stuff. So Scala already has it. Here I have a tuple of a string and an int. And if you're not familiar with tuples, you can kind of think of them as a list, sort of, except that the size is limited at compile time, or like statically what the size is, and statically how many there are and like which types there are, what types all the elements are. So if you use a tuple instead of a list, for the same kind of use case, a tuple is better because you won't get these array index out of bounds exceptions that you might get if you tried to use a list for the same thing. So you may have noticed some of the type annotations on my previous slides. Here's where I finally explain that. So type annotations are usually optional because the compiler can figure out your type for you. You don't have to tell it 1, 2, 3, 4 is an int. Like it's like I know it's an int. Like don't tell me. But if you want, you can tell it for like documentation, or sometimes it actually is required. For parameters of a method, actually they are required, but the return type is actually not required most of the time. So here the compiler can figure out if you're multiplying 3 ints, then that return type is an int. You don't have to tell me it's an int, but if you want to, you can tell me, and I'll tell you if you're wrong, basically. So for generics, instead of using the angle brackets in Java, we use the square brackets. So that's a little different. Classes. Here I've created a new class called chess piece, and basically I've created subclasses for all these pieces. So the first thing you might notice is that in Java, you'd have like the class, and then you'd have a separate method for the constructor. But in Scala, you just have the constructor like inside the class declaration. In here, when we subclass the chess piece, we actually, in the extends like expression, we actually pass the arguments that we have into the constructor here. So there's actually some convenience code for some of these things. So if you write a lot of Java, you have like these classes that just hold values like pojos, I guess. You have like these huge constructors that have like just basically setting, this dot member equals argument. In Scala, you can actually just do that in one line here. We can just put the val inside the constructor name, and it just adds it into the class. You could also do with var if you wanted as well. So this code is equivalent. We've saved 3 lines of code. Hooray. In Scala, we don't have a static keyword. Instead, we have objects. So you can think of an object as a class that has only one instance. It's like a singleton, basically. It's more object-oriented than having static methods. So even though it compiles to the same thing. Yeah. So here we have a method that would be static, but instead it just lives on this object. You might recognize this example, object myapp, def main. So this is basically the same as you would do for a static void main. Instead, you would have to put it on an object to use that for like a, a hello world or something. So a lot of times in Scala, you'll see a class and an object with the same name. This is actually a common pattern. It's called the companion object of the class. And it basically is how you would, if you had a static method on a particular class, it's how you would kind of associate those, is you would have the object with the same name. So we're going to do a small refactor now that we learned about object. I think actually instead of having a chess piece, we actually want to have a chess piece type. And here, the chess piece type just needs a value, like what this piece is worth. If you play chess, like these are the values of the pieces. And then like a character for like printing it out. So now we have objects. There's only one instance of each of these types. They're basically like enums in this case. And then I've also created something similar for the color of black and white, which is basically like an enum. And instead, we have a class for chess piece, which takes a color and a piece type. So now I'm going to talk about case classes. Basically, all that stuff we saw before was already too much boilerplate for us. So we can do even better. Case classes basically implement all the things that you hate implementing in your Java pojos. Your toString, your hash code, your equals, your copy constructor, your getters, and the companion object, which is what we learned about with object. So I basically, you probably can't read this code anymore because it's small now, but I just put case in front of all of these things, more or less. And now, with this magic, we have the comparison of what would look like in Java. I actually had so much space left over on the Scala side, I found space for a GIF to add. One great feature about case classes that the equivalent Java code does not have is this idea of a copy constructor. So if you remember like the name parameters thing, say you have a chess game and you want to just change one thing about it. Like in Java, you'd use a setter to like change one attribute. But in Scala, we don't want to use setters because that's a mutable state. We want to create a copy of it with one thing different. So here, there's a copy method on all the case classes that we make, and it uses those name parameters that we talked about earlier to like set which ones you want to set. So here I have a chess game, like Bobby Fischer and Magnus Carlsen are playing, and at first there's no winner because the game is not over, and then later I say that Magnus wins. And we have a new object. Pattern matching is another benefit you get when you create a case class. So it's like Java switch statement, but like on steroids, which is great. So in this example, what I'm trying to do here is just accumulate the balance of the pieces in this chess game between white and black. So the way that like chess engines work is like they have like a score of the board, and negative means like black's ahead, and positive means white's ahead. In this case, it's not a very sophisticated scoring algorithm. It's just counting the value of the pieces. But basically, I just loop over all the pieces that are in the list. Let's do a for each. And this P basically is I didn't explain the syntax, but this P is basically like if you're in like a for each in Java, like for P in pieces. So here we're matching on this piece, and we're using this awesome syntax for matching where we're saying, okay, here's the possible cases that I'm looking at. Like if there's a chess piece of any color, underscore means like I don't care, it's like a wild card. A chess piece of any color that's a king, like I'm going to skip it because if you remember the king's value was int max, and we don't want to like add that into our total because it's going to give us bugs. We're going to overflow probably. In the other case, we have a chess piece of any type. It's a black piece. We're going to subtract the value of the piece. And if we have a white piece, we're going to add the value of the piece. And at the end, we're going to return the balance. So hopefully that makes sense. This is like a really awesome feature. A lot of functional languages have pattern matching. So if you've done that, you'll probably recognize it. But also, it's not just for case classes. Like you can use match like you would use a switch statement in Java. So here I've matched on the ISO country code of these different countries, and I've returned like a string about the country. You can see that on top of just matching exactly what we have, I can also do these little if guards that say, okay, if the length is not 2, then it's like not the right size. And this underscore is like saying is anything. I don't care about the name of the variable. Just anything else. It's like the default for a switch. Also notice there's no need for a break between these cases, which is good because everyone has had that bug before. So traits are the next. The third part of the family of classes and objects. So a trait is basically like a Java interface, but with a few extra abilities. So this trait, I have a chessboard. It basically is equivalent to a Java interface if it's used like this. So I have one chessboard trait, and I can have these implementations of chessboard. In this case, I'm using a vector to store the squares. And in another case, I'm using like a bitboard, which is like an advanced data structure for storing chess positions. And here I just implement the methods, and it's just the same as the Java interface with a nicer name, I guess, or a different name. I don't know if it's nicer. But there's actually more you can do. So here I have a quacking trait and a duck, and I can mix in this trait like when I construct the class. So I have a new duck, Howard the duck, and he has quacking. So now the compiler knows, or your IDE knows, your compiler knows that this duck has a dot quack because it figured it out. That's not usually how you would use it. Normally you would actually just, when you create the class, you would put the trait here. And I can do the same thing. I can create a Donald the duck that also quacks. One side note is you can also use traits as modules. So if you have some class and you have all these different sort of not totally related parts to it, this is a very contrived example, and it probably isn't the best example. But you can see I have like the chess AI, and like part of it is the engine, and I want to be able to like mix and match and compose like my objects, so I can just mix and match different traits. And all I need to do is like have these abstract methods that say like things that my trait depends on, and then when you sort of put together all of your traits into a class, at compile time, the compiler will know if you have all those dependencies satisfied. So it's like dependency injection, but it's like safer, it's type safe. And there's a pattern for this in Scala called the cake pattern. I think it's kind of falling out of favor, but it sort of takes this to like a extreme level. So some tail recursion. So hopefully, like most of you learned about this at some point in like university, but let's just kind of review. We have this. You may be wondering, like when I say we're only going to work with immutable objects, like how do you do anything with only immutable objects? Like it doesn't even sound possible. So this is one of the sort of low-level primitives you use for doing that kind of thing. We have a method called hasItem, and it takes a list and the item we're looking for, and we want to see, does this list have this item? So the sort of standard way to do this in a functional language without mutating any variables is to use recursion instead of a loop. So we have three possible cases that we're outlining here. Nil, which means this means empty list. So if we're having an empty list and we're looking for an item, we know, okay, it's not there. The list is empty, it's definitely not there. So we can just return false. If we have this cons, this is called cons. This basically means we're deconstructing the head and the tail of the list, and the head is the first item, and the tail is the rest of the items. So here we're deconstructing it. We have a head and tail, and we have a guard on the case. We say if the head is the item, hey, we just found our item, so you can return true. And then the other case is saying I don't care what the head is because I don't need it anymore, but give me the tail, and I can recursively call hasItem on tail and go back in. So this isn't always so great, right? Because sometimes your methods aren't tail recursive, they're just recursive. So here we have a sum, which takes a list of integers to sum, and we want to add them all together. We do something similar. We say empty list. Well, that's sum of 0. That's easy. And then we say, add the head to the sum of the tail. But as you might have predicted, if you try to actually run this, you'll get a Stack Overflow error because you're basically using your call stack to store all the things you're trying to add up, and then you're unwinding the call stack and adding them back all together. So there's a technique you can use to avoid this. And by the way, this annotation, tailrec, it basically will give you a compile error if you have a method with that annotation that's actually not tail recursive. Because in Scala, if the method is tail recursive, then it can compile it to a while loop and basically be more efficient. It doesn't need to use the stack. It might make your stack traces harder to read, but that's sort of a different problem. So here we have a list. Oh, this is not the right code. I'm sorry. Oh, well. Basically, what we would need to do is have a helper method inside of it that takes another argument of an accumulator. We initialize that to 0, and every time we pass it through, we would add that accumulator. So that's true. Let's just do this right now. We'll see if I can live code this. Oops. Oh, no, I'm lost. Oh, dear. What have I done? Can I edit the slide? Okay, I don't know how to edit the slide. This is like some weird slide thing I found yesterday. Not yesterday, but it's basically an argument to the method. So you will. Can I exit this presentation mode? Sorry about this, everyone. Maybe if I'm not in live. No, it doesn't like me. Okay, I can do this. I'm sure we can do this. There we go. Tail recursion. Okay, so, oh, I wasn't in edit mode. No, start over. Okay, so I chose this because this is code highlighting, and I'm tired of like doing my own code highlighting in presentations. So we'll have like an inner loop that takes our list. And it also takes an accumulator, which is an integer. So this is going to be more or less the same in here. And then we're going to return inner loop of list and 0. But now we actually have to make it correct? So instead of 0, we'll return the accumulator. And instead of doing a head plus this sum thing, we'll just do list of, inner loop of tail. And the accumulator is now head plus accumulator. So we're updating the accumulator. Okay. Right, because that's one place where you actually do need to give a return type is a recursive function, because I guess if it tries to use inference to figure it out, then it kind of just goes into a loop trying to figure that out. So this is a good time to introduce the Scala REPL. Basically, you're in command line and you just type Scala, and you basically get like a live coding thing. So let's see if my function worked. Live coding is always a good idea. No, I gotta import that. So if I spell Scala, it would be awesome. Okay. I annotated the wrong, I annotated the wrong place, so that is my mistake. Let's just get rid of the annotation. We should be annotating inner loop, not sum, because that's the tail recursive one. Okay, so now we have sum. We can give it a list of this. Let's just make sure it works. And let's give it a harder test. Let's say 1 to 10,000 to list. Boom. Great. Is that? Okay. That doesn't look correct, actually. Yeah.
It's probably overflowed.
No, I don't think it's overflowed. I think what happened is there's a bug. Right? Let me just sanity check this. 1 to 10. Okay, actually, that's right. Okay, I guess I just don't know how to add integers. And my code does. Hopefully. If this is a bug, I'll find out later. I'll look into it. Yeah, leave this page. Let's go. Actually, we can just do preview. Is this big enough, or did the font size, when I go back into full screen, is the font still the same size? Okay, I was worried it wasn't for some reason in preview mode.
Maybe you can tell why it's actually better to do it this way.
Yeah, so, well, the real reason is because you won't get this stack overflow error.
Oh, compared to while loops.
Yeah. Oh, compared to while loops. Well, I mean, it's a matter of preference, I guess, but in this way, you are not using mutable data, and you won't have certain types of bugs that you would get when you're using mutable data. And theoretically, you know, you could parallelize this depending on the algorithm, because if you're not using mutable data, then it's easy to use multiple cores. And do you have any other ideas about why it's better?
Well,
Do you have something specific you're thinking of?
Haskell is basically mathematical programming, so you can write proofs as well as such programs if you don't have variables.
Yeah. Okay. So next we have the collections. We're going to talk about all the different collections Scala has. You know, we're using we're running in JVM. Like, we have access to all the Java standard library. Like, you might ask, why does Scala even need to have its own collections? Aren't the Java collections great? I mean, yeah, they're great. They have good performance and everything, but they're all mutable, and they have like not nice APIs to use from Scala. So if you ever like tried to make like a new hash map with that, like in one line of code in Scala, like, or in Java, like it's a nightmare. So you have to use like Guava or something to even do that. So we'll start with the most obvious one. We've been looking at this one already a few times. It's called list, and it's parameterized on a type. And here we have a nice syntax for creating lists. We can look at the length, but of course, if you're just checking for the length of 0, you actually don't want to do this because it really is a linked list. And so the length is an O of n operation. We can get the second element, or I guess actually the third element, because it's 0 base index, of course, using these like parentheses. We can get the head of the list and the tail of the list, and obviously there's more than just this. This is just what I felt like was important. We can use the cons operator to make a new list, which like appends or prepends a 0 to the list. And we also have an option. So an option you can think of as kind of like a list of 0 or 1 elements. It's what you would use in Scala instead of using a null pointer. So Java 8 now is optional. Maybe some of you have used it in Java 8, or maybe used it in Guava before Java 8. here we have an example of what you might use it for. So say we want to maybe look at the square A3 on the chessboard and see, is there a piece here? So we return an option of a piece instead of a piece itself. And we can match this option. We can pattern match. We can say, because an option has two subclasses. It has a subclass called none, which means there's nothing here, or a subclass called some, which means there's exactly one item here. So we can pattern match on it, and we can say in the none case, we can behave differently than in the some case. And when you pattern match, you're deconstructing this option, and this piece is now a variable inside this scope, and this piece is actually of type chess piece, not of type option chess piece. So you can do all the operations on a chess piece, get the value or get the character. And if you use this correctly and use this everywhere in your code, and you never use the word null, you can actually completely make null pointer exceptions impossible. So that would be the ultimate goal. Here's sort of how that happens, as you've probably seen before in your own code, and I assume. So when you have this something like a Java map which returns null if the element isn't in the map, or if the element in the map is null, both of those will return null, then you can't just call toString on it. But if you were in Scala, you actually could do that. You could, the Scala map.get actually returns an option, and on option you can call .forEach, and a forEach on an option is like a forEach on a list. It just goes over all the elements. If there's one element, it does your thing. So in this case, I print it. If there's no elements, it does nothing. So it'll just skip. So the next useful thing is map. Map is just a trait. It's not an implementation, but it is a trait for immutable map types. So here I've created a map, a Unicode 2-piece. So I took some chess Unicode characters and I mapped them to the piece type. And we can basically add key and values to the map and get a new map. So since it's immutable, you can't obviously just set into the map. You have to create a new map. If we try to do .get, it returns an option, as we saw in the last slide. But if we try to do this syntax, which you shouldn't do this syntax, because it will return a no such element found exception, or no such whatever. It throws an exception, which you don't want in your code. But there's a safer alternative where you can do get or else, which basically says if this key exists, then return the value. Otherwise, give me this other value. So in Scala, we have array. And array is just exactly the Java array. It's not different at all. One difference is the syntax for accessing an element. So in Scala, all the collections are the same the way you access them. You always use the parentheses. There's no special case for arrays like in Java where you suddenly use the square brackets for one collection but nothing else. Here we've created an array with these two pieces, and we can set this. So it looks like this pawn has been promoted to a queen here. We've updated the array. So obviously there's a lot more in the collections. There's sets and vectors and queues. So I just sort of looked through the source and just started naming random cool sounding things. There's an entire submodule for mutable collections if you need, for some performance reason or for some other reason. There's a parallel collections, which basically lets you do your maps and your other operations on multiple cores, multiple threads. And there's also a thread safe module with all kinds of concurrent hash map and that kind of stuff. So you get the idea. It's a bunch of what you'd expect basically.
So with concurrent stuff, you can actually run map in parallel with elements of the list, right?
Yeah, I think so. I haven't done it, but that's what I've been led to believe. So just another quick survey. Are you guys familiar with the map function? Higher order functions? Okay. So this should be obvious, I hope. Here we have a method add1, which just takes an integer and adds 1 to it. And we have a list, 1, 2, 3, 4, 5. Oh, I have a bug or a mistake. So if we map that function onto our list, then basically it just creates a new list where every element in the list has had that function applied to it. So here this actually should say 2, 3, 4, 5, 6, but it's almost correct. We can do the same thing with an option. We can map an option and add 1. So I have my age is 27, but if I add 1, then it would become 28. So it does what you'd expect in the case of a none. So if we have another option int that's just none, like a dog's age, I don't have a dog, so it's none. We map that, and we just get back none. So it does nothing, just like it would if you had an empty list and you tried to map. So from now on, we're going to use like a shortened syntax for these functions because it's a lot of time to write all these defs. You can just do like an inline function like this right here. And even shorter, you can use this little underscore trick sometimes. If you only have like a really simple function, then you can just use underscore, and it says like take the argument and place it in this underscore spot. So basically, you can think of it as currying the plus operator, but that's maybe, I don't know. So now so on all these examples before, I was just like adding one, but you can actually, the map's type, if you have a collection of type A and you have a function that can convert an A to a B, then map basically gives you a collection of B. So for the previous slide, all the A's and B's were the same. It was maybe not obvious that you can change the type. So here I have some examples of that. I have a list of pieces, and I get their value out. So I go from a list of chess pieces to a list of integers. And similarly, I have a list of cities, and I want their length. I can map underscore dot length, and I get a list of integers that corresponds to the size of those strings. So just as a quick note about what one of my assertions earlier was about how there's going to be more errors caught at compile time compared to Java. So when you use map with an option, you basically have this ability now. So in Java, say you would just like want to pull something off of a reference. You first have to check, is that reference null? Okay, if it is, then I'll just return null or whatever. And otherwise, I'll do this. Whereas in Scala, you could just map on this, and you would actually get an option of int now, an option of the age. So the difference here, it may look the same. Like if you just, like null is kind of like none. It's kind of the same thing, right? Well, there's some differences. Like if you make a mistake here, if you flip your if statement, or if you just make a typo or something, it's still going to compile, right? Like it's still valid code. You can still, at compile time, Java can't tell you if this is null or not. So you'll have a runtime exception. But if you stick to using options, then you can actually avoid those exceptions. And not just that, but like, maybe you did your job and you did all your null checking in your method, but then you just pass back null to someone else. Like you don't know what they're going to do. Maybe they're going to do something crazy and dereference your null pointer. So if you return them an option instead, it doesn't let them even have the opportunity to dereference the null pointer. So I like to think of it like this. Like when I'm writing code in Java, it's like I'm playing Minesweeper, and there's so many bombs. Like every bomb's a null pointer exception. But in Scala, like the compiler comes along and like puts little flags there for me, and I can just like, super easy. Okay, so what if we like have a map where we want to, the function of the map also returns the type of collection that we're mapping over. This might not make sense, but I'll give you an example. Like here we have like a game which has an optional winner, and a chess player which has an optional last game. And say I want to find out who was the winner of the last game of the chess player. Well, if I just do it the way we've learned so far with map, then it kind of works. Like I get this this method, get rating last winner, and I look at my chess player, which is the last game, which is an option of game, and I map that to get the winner, right? So it seems like it sounds like it works. Well, kind of. Like we now have, if we look at like the types, how they line up, remember that if we had this, the way map works is you have an option of A and you map from an A to a B and you get an option of B. Well, in this case, A is just game. We have an option of game, so A is game. Dot underscore winner is this method here from A to B. It's from game to option chess player. But now B is option chess player. So that means if you look carefully, we actually have an option of a chess player. So it's pretty rare when nested options are actually useful. It does happen occasionally if you not want to know the difference between one thing being empty versus another thing being empty. But in general, we don't really care about the nested options. We need like a flat map. So we have it. It's called flat map. This basically does the same Very similar thing to map, but the difference is that in this part of the signature, there's this collection in the output. So we rewrite it with flat map, and now instead we have a chess player of just option chess player. So it'll find us the winner of the last game this player has played, or none if there was no game, or none if there was no winner. So filters, very important if you're using Instagram, but also important if you're using Scala. So here I have a list. What a filter basically does is it takes a method that returns a Boolean. So if you have a list of integers, you need something that takes an integer and returns a Boolean. So here I have such a method. It's mod2 equals 0. When I do this on my list, I filter out all the odd numbers. And if I do this on an option, I filter out just the only. I can filter out or I can leave it depending on the predicate. Here's my favorite. This might be too small. I probably forgot to make this font bigger, but let me see if I can at least make it a little bit bigger. My favorite collection API is actually collect. So what collect does is it does a map and a filter at the same time. So here, remember that previous example of calculating the chess score. Last time I used a var. We didn't really want to use a var because we want to be able to prove our programs to be correct. So here I use collect on the pieces, list of option pieces this time, so it's even fancier than last time. So you can imagine this is the squares, and an option, if there's none, that means that's an empty square. If there's a sum of a piece, that's a piece on that square. So I'm doing a collect over all of the squares. And in the case I have a sum, and it's a king, I don't care about that. It's a 0. In the case of a sum of a white piece, I want to do the positive value. In the case of a sum of a black piece, I want to do the negative value. And then I want to take the mathematical sum of that list. So on a list of integers, you can do dot sum, and it'll add them up. So you notice that I didn't even address the none case. So since it's not defined in this, it's called a partial function here. Since it's not defined, it'll just filter it out for me. So this is the same thing as doing all this code, where you have your pieces and you filter them by if they're defined, which means that the option has a sum, not a none. And you map them to .get, which is how you pull an option, like a t out of an option of t. And then you filter out the kings, and then you map to basically the same code here, and then you take the sum. So, yeah, this is my favorite method. Fold left and fold right. You may remember from university if you took Lisp or something as a class. This is sort of, if you remember the slide about tail recursion, this is sort of the more, most of the tail recursive functions you write can be re-implemented in a fold. So basically, if you've heard of map reduce, reduce is another name for fold. So this fold left and fold right, the difference is basically the associativity of what you're doing. If you're doing addition, it doesn't really matter because addition works in both directions the same way. So here I just did underscore plus underscore. This is creating a new method that just adds numbers together. And all it's really doing is 1 plus 2, and then that's added to 3, and that's added to 4 and 5. It gives us 15. It's a nice way to take the sum. So that might not be very clear from that example. So I have a more specific example here. It looks like I didn't paste all the code in again. But here we're counting the number of e's in a string. Actually, no, this is complete. So what we're basically doing, we do fold left, and the first argument group is the initial value, the initial accumulator. And the next argument is a function that takes an accumulator and a value of the type of your collection. So I can look at this next value, I can say it's an E, and I can add 1 to my accumulator, or if it's not an E, then I'll just leave the accumulator as the same thing. This is probably not the best way to count E's in a string in Java, but it's just a nice example of how to fold. Finally, the last collection method we're going to talk about is group by. So a group by is a really nice thing. I use it all the time. Say you have a list of a bunch of stuff, and you want to group them into sublists based on some predicate. In this case, my predicate is just piece type, and so I get back a map where the key is the result of this function call, and the list is, the value I should say, is a list of all of the things that matched that particular, so all the queens are in here, all the rooks are in here, and so on. Actually, yeah, so thank you for listening. That's all I have for Intro to Scala. And now we have time for questions, I'm sure. How much time do we have?
Questions?
Yeah, go ahead.
Is there any performance gain or performance loss to be expected when you're switching to Scala?
Yeah, I mean, it depends. So the question I should repeat is there any performance loss when switching to Scala? So, I mean, it's going to compile to JVM bytecode, right? So, like anything you write in Java, you could write exactly the same in Scala. You could use vars, and you could basically make the bytecode exactly the same as it would be for the Java equivalent code. But in generally, we don't do that in Scala. We want to write more idiomatic Scala. We want to use this higher level abstractions. And so sometimes when you use higher level abstractions, you're going to lose performance. Like when you use an immutable list, if you don't do it correctly, then yeah, you're going to like have a lot of performance issues, you know. And so I guess it depends on do you actually care about like the milliseconds that the difference is? You know, probably for like your tight loop, that the most important, you know, inner loop of your function, maybe you do care and you want to write that in a very Java style of Scala. But in general, I would trade, you know, higher level code for performance almost all the time, because higher level code's easier to reason about, it's more likely to be correct, there's like, you know, more compile time safety. So you can sort of do both in Scala. You can have like the basically write Java but with a slightly nicer syntax, or you can write like high level, you know, filters and maps and that kind of stuff. Yeah. Yep.
Coming from Python background, can you compare the two languages? What you like more in Scala and what you like less?
Yeah. So you know, I was a Python programmer for a while, and I thought I would never use like statically typed languages. I thought they were basically like the worst, because I had to like use this huge IDE. It was going to take like, you know, 12 gigs of RAM. It was going to eat my CPU, and I had to like, it was like terrible. I saw people were like using Eclipse, and I thought this is a disaster. Like, who wants to do this? I just have like Vim. I have my terminal, and I'm like, fine. But you know, I slowly converted. Like IntelliJ on Scala is great. It's like really good. When I first started Scala, maybe 3 or 4 years ago, it was not good. It was really slow and full of bugs. But now it's actually really good. So for me, what's really changed from switching from Python to Scala is the way I think about solving problems. So it's hard for me to go back to dynamically typed languages now, because I always sort of start with the types, and I want to define my problem in terms of the types. And the reason why I want to do that is because the compiler is good at checking your types. The compiler is not good at checking your control flow, right? So if you can move as much of your logic into the type system and out of the control flow, then the compiler is going to catch more of your bugs. So in Python, you can't do that. Like, there's no such thing as you know, static checking of your types. The Python I write today is well, it's very functional for one. Like, I use like generators everywhere. I still like Python for some things, like for getting something done really quick. It's probably still faster. And yeah, I mean, it's got a place still for me, but I would say Scala has been a huge influence on my style of programming. I also was like an Erlang programmer a little bit too, so I had some functional experience. But even Erlang is like hard to go back to now, because I feel like so disoriented without being able to like statically say like, oh, here's like these, you know, this pattern match. I want to be able to statically say that I'm not missing any cases. So one thing I didn't cover about traits is that you can make a trait a sealed trait, and that's basically like making a class final. So it means that all of the subclasses for this trait are in this file. And when you have that and you do a pattern match on those subclasses, then the compiler can tell you like, yeah, you've got all the cases covered. So.
Short question. What happens if you're a class and you want to use two traits which implement the same method?
Yeah, so if you have two traits that implement the same method, there's basically like a resolution order kind of thing. I don't actually remember off the top of my head what that is. You can test it, and we can test it right now actually if you want to see.
I think
Yeah, it's not as bad as C++. Like you don't have that sort of diamond problem with multiple inheritance because like it's more deterministic, like which order things get called. So there's actually a few things you can do. I don't know if I'm going to be able to come up with an example like this, but let's say like a fish or something. And we what's it like? Maybe swim. Sure. I really shouldn't be live coding. This is difficult. Okay, so this is going to return a string. It's just like, okay, I'm going to say we have a trait animal. And it also has a swim. You know, actually this isn't going to work because this fish should have extended animal because now these aren't going to be seen as the same. I'm not going to try, sorry. Basically, I think it's like a left to right thing. So when you do like your which one they extend, it'll figure it out from that. Yeah, so you do have to tell it like you're overriding something. There's also something a little more obscure called abstract override. And let me see if I can find a really quick example instead of trying to write one. This is like, I've actually never seen this used, but I saw it in a talk once. I guess C# has it too. I didn't know that. So, okay, in Scala you can have a method that's abstract override. What that basically does is like, it's both overriding and it needs to be overridden again. So it gives you like this thing where you can like chain from like every trait and it goes from one to the other instead of just like ending here. That was like something that I thought was crazy, but I've never seen it used in practice.
So I guess early initializers is something which is quite important. Early initializers is something quite important with traits, right?
Yeah, so you can run into some issues with like null pointer exceptions if you mix in things in the wrong order. Even though I told you like, oh yeah, you're going to be solved all your null pointer exceptions. I'm neglected to mention that. So actually, you maybe know more about that than me, or initializer stuff. I don't off the top of my head. I've read about them, but I forgot like how that works.
Well, basically, because of the initialization order of the fields of the traits, you might get null pointer exceptions because of the order of execution or initialization. But when you mix them together, before even applying any traits, you can insert a small initializer which sets the necessary abstract fields to whatever is needed. So, well, it's a very arcane thing, but, well, probably only its parents can love this thing because it's super ugly. But yeah.
It's probably like a sign that you need to refactor if you're running into these issues, in my opinion. But I'm sure there's legitimate reasons why you would design something that way. I can't say I've like really run into it too many times. Any more questions? Should mention my links on here. So these are two really good books. Scala for the Impatient I think is really good if you like already have a programming background. Like most programming books about languages like assume that you know nothing about programming. Like here's how math works. Scala for the Impatient is like the opposite. It's like, hey, we know you probably know Java. Like this is like what's different, and it's like it's a good book if you just want to like learn real quick. And if you want more interested in like the very hardcore functional side, then this is a really good book, Functional Programming in Scala. Also, there's a really, really good Coursera class. Has anyone taken the Scala class on Coursera? Okay, so like pretty good amount of the audience. So you know, it's a really good class. I definitely recommend that. Probably most people who do Scala these days started from that Coursera class. I started from that class. So. And if you have more questions, you can hit me on Twitter or email, chat at Twilio. Hopefully you can remember that. Okay, I guess. Oh, one more question. Can you give them the mic? Oh. Yeah, so I do have a slide on this I can quickly go back to. This one. We have a bunch of, it's like a relatively big company now. So there's different teams. P teams are sort of empowered to use whatever they want to a certain extent. I think like the blessed languages we have are like Python, Java, and Scala. Although even though that's the case, we have a lot of PHP programmers. Like most of the website's still PHP. But yeah, like for my team, like we have some Python people on the team who do like, which is faster to like have them use Python than to have them learn Scala for like the stuff they're doing, because it was like kind of isolated from what the Scala people were working on. But we have, I think, 3 people who mostly do Scala like almost all the time. I occasionally do Java, like if I'm working on some helper library that we share between some of the Java teams or something like that. And I do occasionally do Python. We have people who do JavaScript for like front end stuff, because you can't really avoid that. I mean, you can, but you yeah. Okay, is that everything? All right, thanks.